Good day and welcome. I'm Mr. Simons. In this lesson, I'll be looking at calculus of motion exam questions. So November 2009, question read, Taurus travels in a car over a mountainous pass during his trip. The height above sea level of the car after t minutes is given as st, and s they used to use as displacement, equal 5t cubed minus 65t squared plus 200t plus 100 meters. For those of you that don't do physics, it's just another way of saying distance back in the day. The journey lasts 8 minutes in total. 12.1, they want to know how high is the car. How high is the car? The car's smoking weed. Just joking. How high is the car above sea level when it starts its journey on the pass? 12.2, calculate the car's rate of change of height above sea level with respect to time, 4 minutes after starting the journey on the pass. Interpret your answer to 12.2. How many minutes after the journey has started will the rate of change of height with respect to time be a minimum? Right? 12.1, how high is the car above sea level when it starts its journey on the pass? So st equal 5t cubed minus 65t squared plus 200t plus 100. So when it starts, time is 0. Alright? So there's 0, 0 cubed, 0 squared, 200 times 0 plus 100. Those fall away, so car starts, it's 100 meters above sea level. Calculate the car's rate of change. So when I say rate of change, I want first derivative. Above sea level with respect to time, 4 minutes after starting. So the first derivative, 4 minutes after. So their rate of change, first derivative, 3 times 5 gives me 15t. 3 minus 1, 2. 2 times negative 65, negative 130. 2 minus 1 gives me 1. 1 times 200 gives me 200. They want to know 4 minutes after starting, so substitute 4. So 15 times 4 squared minus 130 times 4 plus 200. My final answer is negative 80 meters per minute. Alright? So that's the answer we get. 12.3. Interpret that negative 80 meters per second. So the height of the car above sea level is basically decreasing at 80 meters every minute. And the car is definitely traveling down the pass, therefore it has a negative rate of change. Does it make sense? So because it's negative, means it's not traveling further up the mountain but down the mountain. And it's decreasing every minute, travels 80 meters down the pass. Right? How many minutes after the journey has started will the rate of change, first derivative, of height with respect to time be a minimum? So minimum of rate of change means second derivative equal to 0. So first derivative, 3 times 5, 15t squared. 2 times negative 65, negative 130. 1 times 200, 200. Second derivative, 2 times 15 gives me 30. 2 minus 1, 1. 1 times 130 gives me 130 and t falls away. And the first derivative of a constant is 0, so that falls away. Because it's minimum, it must be equal to 0. So 30t minus 130 equals 0. Take negative 130 over, it becomes positive 130. 130 divided by 30 then gives me 4,33 minutes. Right, let's look at the next exam question. November 2012, a particle moves along a straight line. The distance s in meters of the particle from a fixed point on the line at time t seconds, t greater or equal 0, is given by st equal 2t squared minus 18t plus 45. 10.1, calculate the particle's initial velocity. So remember, velocity, for those of you doing physics, is the rate of change of distance. So the rate of change of distance there, st given, represents velocity. Determine the rate at which the velocity of particle is changing at t seconds. Then after how many seconds will the particle be closest to its fixed point? So closest, minimum. So calculate the particle's initial velocity. So for initial velocity, time always equal 0. Because they use the word velocity, I have to find first derivative. So there's my equation given. First derivative, 2 times 2, 40. 1 times negative 18, negative 18. Times 0, so there in the place of t, 0. 4 times 0, and it gives me negative 18 meters per second. Right, so that's the particle's initial velocity, minus 18 meters per second. Determine the rate at which the velocity of particle is changing at t seconds. Right, so rate at which the velocity, so rate of velocity is acceleration, or in this case, second derivative. Right, so st, there's my equation given. First derivative, 2 times 4, 2 gives me 4. 2 minus 1, 1. 1 times negative 18 gives me negative 18. Second derivative, 1 times 4 gives me 4. T falls away. Negative 18 becomes 0. So the rate of change in velocity is 4 meters per second squared. Right? Look at 10.3. How many seconds will the particle be closest to the fixed point? So closest, first derivative equal to 0. So my equation, first derivative, 2 times 2, 40, 1 times negative 18, negative 18. Constant becomes 0, so therefore falls away. Make it equal to 0, 40 minus 18 equals 0. Take 18 over, becomes positive 18. So 18 divided by 4, give me t. T equal 4,5 seconds. Right, so hope you follow, hope you enjoy the lesson. Please like, share and subscribe. Look at the last example. Again, the distance from a fixed point S of a car moving towards a fixed point after t seconds is given by st equal t cubed minus 9t squared plus 24t minus 20. 10.1, determine expression for the velocity of the car. So distance, velocity is rate of change of distance, meaning rate of change, I have to find first derivative. So there, having the equation, first derivative, 3 times 1, 3, 3 minus 1, 2. 2 times negative 9, negative 18, t, 1 times 24, 24. So there my first derivative, velocity. 10.2, determine expression for the acceleration of the car. Right, so acceleration is the rate of change of velocity, meaning I have to find second derivative. So my equation reads t cubed minus 9t squared plus 24t minus 20. 3 times 1 gives me 3. 3 minus 1, 2. 2 times negative 9, negative 18. 2 minus 1, 1. 1 times 24, 24. And first derivative of a constant falls away. Second derivative, 2 times 3, 6. 2 minus 1, 1. So t, 1 times negative 18, t falls away. 24 becomes 0. So my acceleration is 6t minus 18. And for 10.3, calculate the time for which the car was reversing. So if the car is reversing, right, it is less than 0, right, the velocity. To reverse, I need some speed. So st equal t cubed minus 9t squared plus 24t minus 20. First derivative of that, 3 times 1 gives me 3. 3 minus 1, 2. 2 times negative 9, negative 18. 2 minus 1, 1. 1 times 24, 24. 1 minus 1t to the power 0 falls away. And minus 20, because it's a constant, becomes 0, so therefore not part. So for the car to reverse, that means the velocity must be less than 0, meaning my velocity must be negative. So therefore I write 3t squared minus 18t plus 24 less than 0. Right? Divide by 3, because it's a common factor. 3 divided by 3, 1. 18 divided by 3, negative 6. 4 divided by 3, 8. Factorize t squared can only be t times t. For positive 8, negative 4 times negative 2 gives me positive 8. But minus 4t and minus 2t gives me minus 6t. Right, so therefore to make these two brackets 0, 2 minus 2 gives me 0, 4 minus 4 gives me 0. Because t squared is positive, my graph would go plus, minus, plus. Right, if t squared was negative, that would go negative, plus, negative. If not following, you can go to Simon's Maths grade 11 and go look at the inequality lessons. They have explained it. Right? But less than 0 is there where it's negative, so it's in between the two values there. So therefore t less than 4 and greater than 2. That 2 inequality signs must always point to the left, to the left, to the left, like Beyonce says. So I point to the left, so my answer goes reversing when my time is between 2 and 4 minutes. Right, so hope you follow. Wish you nothing but the best. Please like, share and subscribe. God bless. Bye.